Um, hey guys, this is Kaushal. Today I am presenting a building science issue found in the 500 milli condo drawing. Drawing set, balcony slab thermal bridging at the curtain wall. I will show what the current detail implies, why it matters for energy and moisture. Then recommend a revised detail that fits the existing design intent. This project is a high-rise mixed-use building with a podium and residential tower above, as you guys can see in the drawing over there. And the residential envelope is mainly curtain wall with spandrel areas, and many units have balconies. Because balconies repeat floor after floor, even a small thermal bridge at one slab edge becomes a big performance penalty across the whole building. The objective is to improve the balcony slab edge detail without changing the overall architectural expression. And in the current detail, the interior slab extends through the facade line and becomes the balcony. Even though there is insulation in the spandrel cavity, the concrete is still a continuous path from warm interior to cold exterior. This is the definition of thermal bridge. And concentrate and concrete is conductive enough that this becomes significant. This also creates cold interior floor edges near balcony doors, and it increases risk of moisture problems around the slab line. All right. So here I have the image of the thermal bridging, and it shows you how heat is lost. Right. So think of a balcony slab like a fin that pulls interior heat outward. That increases heating demand and also can also affect cooling. More importantly for occupants, interior surfaces near the slab edge get colder, so comfort drops due to radiant cooling and draft sensitivity near doors. From a compliance standpoint, Ontario Energy Compliance through SB10 and city performance targets increasingly expect thermal bridging to be accounted for, especially at repeating slab edges. When the slab edge is cold enough, interior air moisture can condense on finishes near the floor line. That can lead to standing and long-term mold risk, especially in perimeter zones. In spandrel areas, if interior air leaks into the cavity and hits cold surfaces, you can also get hidden condensation. So the fix is not the insulation, it is also keeping the air and vapor control layers continuous through the slab edge zone. Okay, let's move on to the next slide. So there are three realistic approaches. The baseline is what we have now. It is simply structurally, but performance is poor, and it is simple structurally, but performance is poor, and moisture risk is longer. Option A is the best thermally. Is best thermally. Keep the interior slab inside the envelope and support balconies separately, but that usually changes structure, detailing, and facade condition a lot. Option B uses a proprietary structural thermal break connector at the slab edge. It preserves the cantilevered balcony appearance and is commonly used in cast in place concrete towers. For this project, option B, in my opinion, is the best balance of performance and feasibility. So let's move on to recommended solution of structural thermal break plus continuous insulation. So the proposed detail adds the thermal break connector right at the building face, aligned with the curtain wall line. The spandrel insulation needs to be continuous and overlap the slab edge zone, so you do not leave an uninsulated band. The air and vapor barrier continuously is critical. The membrane needs to connect from the slab edge area up behind the spandrel and tie into the curtain wall air barrier approach. Also avoid penetrating the thermal break zone with railing force. Keep attachments on the balcony side. Finally, maintain a proper slope and drainage strategy so water does not track back towards the facade. Okay, let's move on to the next slide. So performance is often expressed or reduced linear thermal transmittance at the balcony edge, meaning less heat loss per meter of slab edge. Published studies and product data generally slow the conductor can cut heat flow dramatically compared to a solid slab and can meaningfully improve the effective envelope performance in building with lots of balconies. In practice, this means warmer interior surfaces at the floor line, less risk of condensation, and an easier path to meeting energy targets without overcompensating elsewhere. So in this slide, I'll talk about coordination and constructability checklists. Uh, this detail works only if coordination happens early. Structure needs to select the connector and design for bending and shear demands at each balcony. Reinforcing layout has to match the manufacturer's requirements and modules must be on the site before each pour. The curtain wall anchorage must avoid short-circuiting the thermal break. Fire stoppage and waterproofing detail also need to be resolved. Since slab edges are key transition zone, quality control matters, especially preventing any hardware from bypassing the break. So I would like to conclude by saying that exterior the current balcony slab detail creates a major thermal bridging at every unit with the balcony. I think the recommended revision keeps the design intent but adds a structural thermal break and better continuity of insulation and control layers. This improves energy performance, occupant comfort, and durability and supports compliance expectations in Ontario. Thank you.